Okay, so when you and I think about sea level rise, what comes to mind? Probably something that's happening slowly, far away, maybe a problem for our grandkids. But here's the thing. The latest science is painting a much, much more urgent picture. It's not just happening, it's accelerating, and it's happening way faster than most of us realize.
Just look at this number, 50 feet. That's how much sea level rise some of the world's top climate scientists say is possible by the year 2300. And let's be clear, a 50-foot rise doesn't just damage our coastal cities, it wipes many of them completely off the map.
And this quote from a scientist really just hits the nail on the head. It perfectly captures the danger we're in. We'd like to think we'll see the edge of the cliff coming, right? That we'll have time to stop. But the terrifying part is, we might have already taken that final step without even knowing it, locking in huge, irreversible changes before we even feel the ground start to crumble. So, to really get a handle on this threat, we have to look past the total number of feet or meters. We need to focus on something way more critical: the speed, the acceleration of sea level rise. That is the real story here.
I mean, just look at how fast the rate has been changing. Back in the early 2000s, it was chugging along at just over 2 millimeters a year. Fast forward to today, and that rate has more than doubled. Now, I know these numbers look tiny, but this acceleration, this is what has scientists so incredibly worried.
So what's putting the pedal to the metal? Well, it really boils down to two main things, and one of them has recently turned into a much, much bigger deal.
For a long time, the biggest cause was pretty straightforward: thermal expansion. You heat up water, it expands, simple physics. But then, right around 2005, things shifted. The meltwater pouring off the massive ice sheets in Greenland and Antarctica took over as the #1 driver. And here's the kicker: its contribution has quadrupled in just a few decades. We used to think of these giant ice sheets as slow, almost permanent fixtures. Turns out, we were dead wrong.
You know, to figure out where we're headed, scientists have had to become climate detectives. They're digging deep into Earth's history, looking for clues. And by studying ancient times when the planet was about as warm as it is right now, we can actually get a sneak peek of what today's warming might be locking in for our future.
And this leads to a pretty wild question. How on Earth can we know if a gigantic ice sheet, literally miles thick, completely vanished 125,000 years ago? The answer is, well, it's amazing.
You're seeing that right: octopus DNA. It turns out scientists found that octopus populations living on opposite sides of Antarctica had interbred, and there's really only one way that could have happened. The entire West Antarctic ice sheet had to have completely collapsed, opening up a seaway right across the continent that let them, well, get to know each other.
And this kind of historical data gives us a really stark warning. The last time temperatures were similar to today, about 125,000 years ago, sea levels were 6 to 9 meters higher. That's like 20 to 30 feet. You go back even further to a time with CO2 levels like today's, and the oceans were a staggering 10 to 20 meters higher. The big takeaway here? The warming we've already caused has probably locked us into meters and meters of future sea level rise, even if we can't see it all happening just yet.
But why? Why are these massive ice sheets so fragile? Well, it's not a simple case of ice cubes melting in the sun. The real danger is in these things called feedback loops. They can kick off a runaway effect that, once it really gets going, it's almost impossible to stop.
Think of a feedback loop like a snowball rolling down a hill. It starts small, but as it rolls, it picks up more snow, gets bigger, and moves faster, which makes it pick up even more snow. It's a self-reinforcing cycle. And that is exactly what's starting to happen to our planet's biggest ice reserves.
Now, there are two of these loops that are especially scary. Over in Greenland, the problem is on the surface. As the top layer melts, the whole ice sheet sinks a little bit lower in elevation. That exposes it to warmer air, which, you guessed it, causes even more melting. It's a vicious cycle. But in West Antarctica, the threat is coming from below. Warm ocean water is sneaking in underneath the ice, melting it from the bottom up. This causes the ice to retreat onto a seabed that actually gets deeper the further inland you go, which can trigger a really rapid runaway collapse.
So, let's bring all this science back down to Earth. What does this actually mean for the billion or so people who live near a coastline? Well, it means we're getting dangerously close to a point where our usual bag of tricks for dealing with this, seawalls and pumps, they're just going to stop working.
Because as this quote explains, what really matters is the annual rate of rise. It turns out there's a kind of speed limit for adaptation. Once the ocean starts coming up faster than about 7 to 10 millimeters every year, our ability to keep pace just totally breaks down.
10 millimeters per year. Burn that number into your brain. It sounds so small, doesn't it? But it adds up to 1 full meter. That's over 3 feet every single century. You just can't build seawalls and levees and pumping stations fast enough to keep up with a moving target like that year after year, decade after decade. It becomes an impossible task.
And that leaves coastal planners and communities with a really stark, almost unbelievable choice. Do you spend billions, maybe trillions of dollars on defenses that you know can't keep up and will eventually fail? Or do you start planning for the unimaginable, a managed retreat, moving entire neighborhoods and cities away from the coast? That is the brutal reality we're facing.
So, this all leads to the big question, right? We've all heard about the Paris Agreement's goal to limit warming to 1.5 degrees Celsius. For years, we've talked about it as this bright line between okay and catastrophe. But when it comes to the world's oceans, is 1.5 degrees actually safe?
Well, the sobering answer is no. Probably not. The idea that 1.5 degrees is some kind of safe harbor for our coasts is, frankly, a dangerous illusion. All that evidence from Earth's past suggests that this level of warming might be the exact moment we walk right off that cliff, locking in completely different coastlines for everyone who comes after us. To be truly safe, some scientists think we might need to get back down to 1 degree of warming.
But look, this isn't a message of doom and gloom. Actually, it's the opposite. It means that every single thing we do to fight climate change matters more than we can possibly imagine. Every tenth of a degree of warming that we can prevent directly reduces the flooding, the displacement, and the chaos of the future. The choices we make today are going to echo for centuries.
So, right now, we are standing at a fork in the road. There are two very different futures ahead of us. In one, the seas rise, but maybe slowly enough that we have a fighting chance to adapt. In the other, they rise so fast that adaptation becomes impossible and retreat is our only option. The decisions we make in this decade will decide which path we go down. The only question left is, which future will we choose?